All right. So again, this is the first question. So in the last class, we were discussing, gate questions on the divide and conquer, as well as on time complexities and recurrence relations. Yeah. So we'll keep continuing our discussion. I think we have again 8 to 9 more problems to solve. So please start with this question now. All right. Start with this question, everyone. The question says, assume a merge sort algorithm in the worst case takes 30 seconds for an input of size 64. Which of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes? 256, 512, 1024, or 2048? Everyone, others, have you got the answer, or did you not understand this problem? Can you provide a response? Okay, no worries. We'll see the solution for this. All right. So now, if you remember merge sort, the time complexity that merge sort takes in worst case is what? Is order of n log n. Okay, is order of n log n. All right. So now, see, considering this, small other time complexities, not considering those things, my time complexity becomes n log n. Okay, so n log n takes how much? 30 seconds if the size if of input is 64. Okay, so basically, if my size of input is 64, that means 64 log 64. This takes how much? 30 seconds, correct? So I can just try and write this. This means 64 into some order. You can write maybe something c times of this. Okay, c times of, let's consider the base 2, easier for us. So this will be 2 raised to power 6. Sorry, just a moment. This will be log of 2 raised to power 6 takes 30 seconds. Alright, so c times 64 into 6 take 30 seconds, right? So in 1 second, what is the kind of problem that I can solve in 1 second? I'll use the unitary method. In 1 second, I can solve what? C times 64 into 6 divided by 30, right? Okay. And they are saying what kind of problem or what is the size of problem that can be solved in what? Solved in 6 minutes. And 6 minutes is what? 360 seconds. So this means in 360 seconds, I can solve what? This into this divided by 30 into 360. This will cancel. Okay. Now this becomes 12. All right. Now you have to rearrange little according to c times n log n. Okay. C times n log n. According to this. So this becomes, let me give two twos. Let me just rewrite this as 64 into 2 into 2 into 3 into yeah, and into 2. So 12 I have split into 4 into 2, 4 into 3, and 6 I have split into 2 into 3. Okay. So see what I have is here. This can be written as 2 raised to power 6 into 2 raised to power 3 into 9. Okay. So this guy becomes what? C into 2 raised to power 9 into 9. So this, can I write it as 2 raised to power 9 into log base 2 value 2? Okay, so this becomes c times 2 raised to power 9 into log base 2 2 raised to power 9. So what did you get? The answer n. Okay, so this becomes order of 2 raised to power 9 into log of 2 raised to power 9. So n is what? N is this guy, na, 2 raised to power 9, because it is n log n. So n becomes what? 2 raised to power 9, which is 512. Little rearrangement had to be done to make sure we get this 512. Is this clear to all of you? Yes or no? So option B will be correct. All right. Salesh and Sai and Salesh and Sai, is this clear to you?
Sir, can you repeat it?
So which part do I have to repeat?
That C dot 64 into 60 divided by 30 now, sir.
See, 1 second, I am taking this much time. Okay, 30 seconds I am trying to take. I am trying to solve this size problem. Okay, so in 1 second, how much sized problem I'll be able to solve? C into 64 into 6 divided by 30 seconds, correct? Unitary method. Yeah. So in 6 minutes, what is the size of the problem that I can solve? Into 6 minutes. And 6 minutes I have to write in seconds, okay? Because I took, this was in seconds. So this I have to convert in seconds. This will be into 360. So after multiplying by 360, I did little rearrangement so that I can write this term as 2 raised to power 9 into 9. Okay. Now 2 raised to power 9 into 9. I'll just multiply a log base 2 value 2 with this. So this 9 will be taken in the power. You get 2 raised to power 9 into log 2 raised to power 9. And that's what? Order n log n, correct, for merge sort. So 2 raised to power 9 into log 2 raised to power 9. And hence n is what? 2 raised to power 9. Because time complexity for merge sort is order n log n. Clear? Alright. So next is this question. Try this. Try this question. This question also came for 2 marks. Anyone who got the answer for this? All right, okay, completed. Anyone else who need more time to solve this? All right. Gayatri, do you need more time or? Okay. Yeah, so good, Sanjeev. 198 is the right answer. So yeah, this question looks a bit tricky. Okay. The reason is it's not really simple to solve. I agree on this point. So let me just write what we have. An is equal to what? 6n square plus 2n. 6n square plus 2n plus an minus 1. All right. And the second thing is a1 is given to you as 8. All right. You're told to find what is, basically you need to find what is a99. Okay, we'll do that. Now, if I try to find a2, you know your n is this 2 square plus 2 times 2 plus 8 and so on. This will become a little, you know, tricky method. Then you calculate a3, a4 and so on. This is going to take forever for you to find a99, right? So what I'll do is I'll do some modification in my recurrence relation. I'll write an minus 1 is equal to 6n square plus 2n. Okay, this is the recurrence relation originally given to me. Now what I'll do is I'll try to write replace n with n minus 1. Replace n with n minus 1. Write an minus 1 minus an minus 2 is equal to 6 times of n minus 1 whole square plus 2 times of n minus 1, replacing n by n minus 1. Okay, so if you add these two, an minus 2, because this and this will cancel, is equal to what? 6n square plus 6n minus 1 square plus 2n plus 2n minus 1. Is this point clear to everyone till now? An minus an minus 2. The same kind of thing what we used to do in substitution, right? What we used to do in substitution. All right. So now I will use that same equation again, this equation again, and replace n with n minus 2. Okay. So you get a n minus 2 minus a n minus 3 is equal to 6 n minus 2 whole square plus 2 n minus 2. Okay, and similarly I can write a n minus 3 minus a n minus 4 is equal to 6 n minus 3 whole square plus 2 n minus 3. So if you check over here, this equation that I got, what you do is in this equation you try to add this term and then this term. Okay, so when you add this term and this term, minus a n minus 2 plus a n minus 2, this will cancel and this is also cancel. Okay, so finally you get is a n minus 4 is equal to 6 times of n square plus n minus 1 square plus n minus 2 square plus n minus 3 square plus 2 times of what, n plus n minus 1 plus n minus 2 plus n minus 3. All right. So now if I try and write this so that this becomes 1, okay, this guy becomes 1 and this becomes an. So if you see the pattern here which is going is, if you have n minus 4, that means we have terms till n minus 3. Okay, so if I keep continuing this pattern, can I end up at this point, that an minus a1? Can I end up over here, everyone? Sai, is this clear to you as well?
Yes, sir.
Okay, so I'll end up over here. So the RHS will be what? See, when I had n minus 4 here, I had n minus 3 term. That means one more than this guy. One more than this guy. So if this is 1, last term here will be 2. Correct? This is important. So you say n square plus n minus 1 whole square plus n minus 2 whole square till what point? Till 2 square. Okay? Plus 2 times of the same term over here, n plus n minus 1 plus n minus 2 plus up till plus 2, right? So we'll end up over here. Now what I'll do is I'll just rearrange this so that it is visually better. An minus a1 is equal to what? 6 times of 2 square plus 3 square plus 4 square plus n minus 1 square plus n square plus of 2 times of 2 plus 3 plus 4 plus n minus 1 plus n. Okay, this you understood, right? Now see, this is sum of first n square, sum of square of first n natural numbers except 1. 1 is not there. Okay, so let me do a small modification here. An minus a1 is equal to 6 times of, I'll write 1 square also up till n square and subtract 1 square. Alright. Similarly with 2, I'll add 1 and subtract 1. Right. Now an is what? I don't know. I need to find. Okay. And then a1 is 8, which is given to me. So this becomes what? 6 into 1 square plus 2 square plus 3 square up till n square minus 6, right? 6 into 1 square will be minus 6 plus 2 into 1 plus 2 plus 3 up till n minus 2, correct? So here I'll have minus 6 minus 2, that is minus 8. This and this will cancel combinedly with this. Okay, so I get an is equal to, now I'll write the summation. So these are first square of first n natural number, sum of square of first n natural number. So this will be n by 6 into n plus 1 into 2n plus 1, right? So this 6 and 6 will cancel, and the other term will be 2 into n plus 1 by 2. Correct? 2 and 2 will cancel. So what I have over here is n into n plus 1 into 2n plus 1 plus n into n plus 1. Correct? I have this with me, and this is an. Alright? So now an is equal to what? I'll take n into n plus 1 common. So I'll get 2n plus 1 plus 1. So this becomes n into n plus 1 into 2n plus 2. So I'll take 2 common and I'll get n plus 1 again. So I'll get 2n into n plus 1 whole square is equal to an. So I got the general value of an. Now you calculate a99. A99 will be what? 2 into 99 into 100 square. Okay, and this value they are saying this is equal to k into 10 raised to power 4. Just put in the value and try to solve. This and this will cancel, so k becomes what? 198. Little bit solving is required after this point. K becomes what? 198. Is this clear to everyone? Yes or no? Only thing is little management regarding solving was required. Okay, apart from this there's not much in the question, but this came for 2 marks. Yeah, one moment, Sai. Yeah. This one? Okay. Meanwhile, if any one of you have any doubt, you can freely ask. Sai, let me know once you complete. Alright, so let's move to the next question. These were some good questions which came in GATE. Okay, in the past 7-8 years. And this gives you an idea of what you can expect in GATE, alright? So it will be mixed of everything. So we have to be prepared from all ends. Alright, now try this question. So they are saying, assume that the algorithm considered here sort the input sequence in ascending order. If the input is already in ascending order, which of the following are true? First, second, third, and fourth, you have to tell me which of the following are true. Try this. This is an easy question, came for 1 mark. Yeah, so everyone completed this. Everyone, please give me a response. Sai, you also completed? Okay. See, so in this question, they are saying input is already in ascending order and you have to sort it in ascending order only. Okay. So this we already know, right? We have discussed this in merge sort, that merge sort perform worst when the sequence is either in ascending order or in descending order. And you know why? Because partition algorithm will not be able to divide the array into two parts. It will always be skewed towards one of the sides. Okay, so this statement is absolutely true. Now how about bubble sort? Okay, and similarly third statement can be false. Quickly, merge sort runs in order theta of n time. This is also false. Okay, because merge sort always takes order n log n time. Okay, and fourth one is also true, right? I'll come to second one. Fourth one is also true. The reason being insertion sort runs in order n time. Yeah, insertion sort when the array is already sorted, and that too in ascending order. Okay, if it is in ascending order, then it is basically checking with the last element, and you know how to run it, right? So it will always check with this guy. This guy is sorted, so it will check the this guy. This guy is checked with this guy, so it is already sorted. So no swaps basically. So then third guy is checked with second guy, sorted, so no swaps and so on. Okay, so only n number of comparisons will happen. So that's why theta of n, and zero swaps will happen, right? Now we check bubble sort. So in bubble sort, what will happen is they are saying this runs in order n square time. Okay. So in bubble sort, what will happen is doesn't matter what you do, always you try to find, you try to, compare first two elements, and if nothing, if that's an inversion, okay, then you swap them, otherwise you keep them as it is, right? Now if this element is less than this element, so then you don't swap, and similarly you keep on checking this. So after single iteration of bubble sort, at the end you will have the largest element. Okay, after second iteration you will have the second largest element at its proper position, and so on. Now the thing is, in the options, if you check, remember I told you a version of bubble sort as well, where if nothing changes between two iteration, you can stop over there. Yes, I told you a modification in that bubble sort. Yes, you remember, everyone? Modification was if there is no change in two of the iterations, there are no swaps basically. So you can say the array is already sorted. So what you'll do is basically, since they have not mentioned three options, like, because we know first and fourth are true. Okay, so first and fourth, there's only one option with that, so that's why you have to mark D. Okay, if you apply modified bubble sort over here, then of course it will clear out things in order of n time only. Okay, it will say that the array is sorted in ascending order in order of n time. So in using modified bubble sort, statement 2 becomes false. All right. So I hope this point is clear. Using modified bubble sort, statement 2 becomes false. Otherwise, it was true. So any doubts to anyone in this problem as well? All right. Okay. So let's see the next problem now. I think we have some more problems left. Okay. All right, try this problem now. Okay, and sorry, this value got cut. I'll just write it over here. Okay, this is nothing but return. Okay, this is the return. Try this problem. This is also a very good question, came for 2 marks. All right. Anyone who got the answer for this? Anyone else? Okay. Take your time. Take 1 more minute, complete the question. All right. So last 30 seconds. People, please respond. Quickly tell me what answer did you get? All right. Let's discuss this now. So in this, what they are saying is the given diagram shows the flow chart of a recursive function an. Assume that all statements except for recursive calls have order of 1 time complexity. Okay. All statements except for recursive calls have order of 1 time complexity. So if the worst case time complexity of the function is order of n power alpha, this is the worst case time complexity, then you have to find what is alpha. Okay. So let's understand the flow chart now. Okay. So it is saying program will start and a will call a by 2. Okay. A will call a by 2. Now over here it has to make two decisions. One decision is you go take this path where you'll again call a n by 2 and you will return. Okay. Otherwise you'll call two times, right? So what will be the worst case path in the flow chart? You have to observe the worst case part in the flow chart. Is this point clear to everyone? Please observe the worst case part in the flow chart. All right. So this is calling once, but this is calling twice. So I will say that this will be the uh, uh, in the worst case path, these will be the connections. Okay. So again you come here. Now from here you have to make decision, either you return or you go and call again. Of course, because I need to find what is the worst case time complexity, so I will make a call again, right? Yeah, right side you move. Yes, after right side, then you again make a call. So you'll not move in this direction, you'll again move in this direction. Again, you make a call and you come here. At this point, you will again make two decisions. Either you go right or go left. Now, since left is again calling one, so I'll move left. So this is the worst case path. Please understand. From here, you move to this point. From here, you move to this, and this. Is worst case part clear to everyone? Yes or no? Right? So now since this is the worst case path, what you have to do is you have to add up all the time complexities. Okay, I'll just clean up the graph. So first is first call, second call, third call, fourth call, and fifth call. That means my time complexity becomes what? Tn is equal to 5 times Tn by 2 plus anything extra is there which is taking some substantial amount of time. No, others are return and these decisions, right? These decisions, they are saying that assume them to be constants. Okay, so this is the recurrence relation you have to solve. Okay, so this I have already discussed. When you try to solve this you'll get as when you write the kth term, this will be 5 raised to power k into t of n by 2 raised to power k plus k. All right, so now n by 2 raised to power k is equal to 1. So from here k is equal to log n base 2, right? So that means this becomes 1 and this is your k, right? So you have 5 raised to power log base 2 n, and of course this guy will be nothing but log n. So this guy will be more. So you can just concentrate on this guy rather than concentrating on this one, right? So now this value, now there's a property. If I have 5 log 5 raised to power log 2 base n, log 2 log n base 2, I can swap these two values. Okay, this is equal to writing 5 log 2 base n base log 5 base 2. Okay, so now you have to find what is this. They are saying as order of alpha. So alpha becomes what? Log 2 base 5. So if you want to quickly check the value, just calculate what is log 5 base 10 and log 2 base 10. Okay, so this becomes 698 and this becomes 0.301. So whatever value you get from here, that will be your answer. So you get, I think, somewhere around 2 point something. Yeah, is this concept clear to all of you? Is this concept clear to all of you? Yes? All right. So let's see the next problem now. Yeah. One moment. I hope. Yeah. Okay. This is also an interesting question. Okay. Try to solve this one. All right, so can I discuss this? Anyone still trying to solve this problem? All right, so let's see the solution for this. See, for this, you have to consider these functions, okay? So now you have to see, according to asymptotic time complexity, which one is greater, all right? So what this means is order n or order log n, which is bigger. That's what we want to say, okay? So I'll just try and compare now, okay? So out of these five, which is the smallest one? Can you tell me? This guy will be the smallest one because see, as n increases and becomes very large, this guy turns out to be zero. Okay, this guy turns out to be zero. Okay, so this is why rest anyone will not become zero. The reason being either n is in numerator, either n is in the numerator or n is not there. Okay, but here n is in the denominator, so this guy should be the smallest one. So that means the first guy should be this. Second, if you see, apart from all these four, only this guy is the one without n in the numerator. So second is of course this, right? Now, out of these three, okay, out of these three, n is the biggest, right? This is n power half and this is log n. So you know that out of these three, n is biggest. So n will be written here, okay? Here you will have n and log n, right? Both. Sorry, uh, n 1 by 2 and log n. Now the question is how to compare these two. Anyone has got any idea on how to compare these two? Anyone? All right, so I'll tell you a general technique, Sanjeev, to compare. Okay, see what you do is you just write these two one side. Now I want to try and convert them into something that I can compare, right? I can compare n and log n. I can compare log n and log n, right? So what I'll do is I'll take log both the sides. Let me take log both the sides. And now this becomes half log n, 1 by 2 log n, and this becomes log n. Now, can you tell me which one is bigger? Half log n is bigger or log n is bigger? Which one is bigger? In general, which one is bigger? Because n is obviously a huge value. Yes. So this guy is bigger. Hence, this guy will be greater than log n. Log n. Okay. This guy will be greater than log n. Hence, your answer would be log n, comma root n. Okay. This is your answer. Everyone understood? 100 by n, comma 10, comma log n, comma root n, comma n. So 100 by n, 10 log n, root n. B is correct. Just observe this once more and I hope everyone is comfortable. Okay. So next we are going to see, I think few more problems are there. Yeah, this is also an interesting question. Try to solve this. Okay. Let me just check how many problems are there. One. Then this is there. This is there. I think this will be the last one. Yeah. All right. Yeah, three more problems are there. Let's quickly finish these. Okay. Please try them. 5. Okay. Everyone got the answer for this? 2 people are saying 5. Okay. All right. Most of you have got the right answer. Now the real question is, anybody thought that the answer is 6? Anyone? Because this is a NAT question, right? Nobody thought the answer is 6. Okay, somebody please tell me, how did you got 5? Anyone? Exactly. So worst case is 30 zeros followed by a 1, or you can say 1 0 1 0 and followed by 30 ones, right? So see, what you have to do is, they are saying consider a sequence of zeros, and after zeros you have ones. The problem is to find the smallest integer index I such that ai is equal to 1, okay, by probing the minimum number of locations. Now see, they are saying worst case probing, and by probing minimum number of locations. Okay, so you have to give me the best algorithm. So you already know the best algorithm is what? Binary search. Okay, so what you'll have is, you'll have this element. Okay, and I'll only consider the worst case scenario. So let's consider what Sanjeev is saying. Okay, 0 0 0 0, last is 0 and this is 1. Okay, so I have to find what is the location of 1 now. All right, I have to find what is the location of, yeah, the smallest from which 1 is starting, right? Smallest index. So first is, you start from 0, okay, and this is 31, right? So 31, using 31 you will divide the array into 2 parts. So you'll end up at the 16th element, correct? A16 you will end up, which is 0. Okay, this is the, for I'll basically, instead of just doing log n, I'll try and count the probes, because this is an NAT question. So counting the probes will of course help me to get the right answer. Okay, A16. So 15 elements are left here, 15 elements are left here. So first thing is, I'll remove those 15 elements. Since this is